Hey all, thanks for joining me. And again, we're talking about sine and cosine graphs today. And I just wanted to remind you, when we're talking about theta as an angle, typically when we're doing this, we'll be using it in radians. But remember, just keep in mind, this is like the same as 90 degrees is pi over 2, 180 degrees is pi, 270 degrees is 3 pi over 2, and 2 pi is 360 degrees. And then, of course, negative pi over 2 is negative 90, and negative pi is negative 180. Okay? So with that said, we're going to be talking about, in class, we really made sure that we understood where the sine function graph comes from and the cosine function. Remember that the sine is the vertical change in the circular function, right? It's a vertical change. So there's a couple of things we need to know. Number one is we see that there's this pattern in sine. So like if I look at this is the first point, the next time it gets back to that point before it starts the pattern back again, it's right here. So we see this piece of our graph is kind of that initial pattern of how the rest of the graph goes. This is called right here the period of how long it takes to get back to the cycle before we repeat it. So this period is length of 2 pi. So that tells me every distance of 2 pi in our angle, or we could say 360 degrees, that will tell me that that's how long we have to go before we start the cycle over. And then the other thing I noticed here is that there's something called an amplitude. And an amplitude is where we go from that middle axis to the peak. So I see the tallest peak is here to that axis is a difference of 1. So we say that that amplitude is 1. And it's also the same distance from this middle line to the bottom, which we know is right here, which also shows that amplitude is always positive. It's an absolute value. Okay, we also see here, and we'll talk about this in a minute, but we see that there's x-axes, or x-intercepts, I should say, here where it hits the x-axis, here at pi, and then 2 pi. We also see that it hits, let me clean this up a little bit, it hits right here as well. It hits right here as well. So our x-axes, or our x-intercepts are there. Let's talk about cosine. The period of the cosine, again, if we're starting here, we want to know when does it get back to that point, start the cycle over again. We know it hits that point again right here. And that distance from here to here is 2 pi, or you could say 360 degrees. And then the amplitude is actually the same as sine, where we go from that midline to the peak, which we know is 1. Okay, so this is our amplitude. Okay, so what do we know about both of these graphs? We know both of them have an amplitude of 1, and they have the same period of 2 pi for both a sine bx and a cosine bx. And you're probably wondering, like, why, Mrs. Sells, do we see an a and a b with sine and cosine? Because that's where we're going to identify where the amplitude is. So A tells us that value of the amplitude. Whatever number's in front, if there's nothing there, we know there's a coefficient of 1. That tells me the amplitude is 1. And then B is a little bit different. We know a typical period for sine and cosine is pi, 2 pi, I should say. So B tells us that we are going to multiply 2 pi times 1 over whatever b is the period. So the period is a little bit more tricky because it doesn't tell you directly what it is, but we have to multiply 2 pi times 1 over whatever that number b is to find the period for it. Okay? So for example, if I want to graph 4 times the sine of x, remember we're plugging this into a sine bx. So I see that 4 is a, and that there's technically nothing in front of the x. There's a 1 here, so b is 1. So if a, put a different color, if a is 4, That's the amplitude. And if b is 1, then the period is 2 pi, because it's a typical period for sine, times 1 over 1, which is just going to stay the same. So the period stays the same for sine, but the amplitude is going to be 4 now. So I know when sine is, when we're dealing with sine, we always start with sine of 0 is 0. And we know our pattern that we go next is typically up to 1. But in this case, our amplitude is going up to 4. So instead of going up to 1, we're going to go up to 4. But then we're following that same pattern that we always have for sine. And we know sine of pi is 0. And then instead of sine of 3 pi over 2 is negative 1, we're going to go all the way down to negative 4. Because again, it gets multiplied by that 4 there. And then we come back when sine is at 2 pi. We come back up to the 0. So this is our graph for sine b. Now remember, regular sine would look like this. It would only go up to 1 and negative 1, so it would look something like this. So the only way that this one changed is that it got multiplied by 4 and the amplitude stretched a little bit to 4. Now for this one, we're looking at y equals cosine 4x. So this is y equals, remember, a cosine bx. So remember, a is 1. So the amplitude is going to be 1. And the b is 4. So if b is 4, that tells me for cosine, a typical period is 2 pi. And we're going to multiply it by 1 over whatever b is. Well, 2 pi divided by 4 times 1 over 4 is really, if I simplify this, this is 2 pi over 4, which can reduce to pi over 2. So instead of ending at 2 pi, where we normally would, we're going to end at pi over 2. So we're going to be stretching this out a little bit more. So instead of ending at pi over 2, I know half of pi over 2 is pi over 4. This will be half of pi over 4 is pi over 8. And then 3/4 of, let's see, pi over 8. Pi over 4 is 2 pi over 8, so that's going to be 3 pi over 8. And this is going to have our same pattern, but instead of going all the way to pi over 2 pi, we're going to go and end here. So we're going to start at cosine, starts at the peak, and then we're going to go down, down, up, up. Okay. And that's all we're going to cover today, and we're just going to be graphing these today for our lesson. Thanks.